Today we're going to talk about graphing cosine. So yesterday we talked about graphing sine and using the unit circle, and so now it's going to be cosine. So recall that on our unit circles we're using degrees. These would be the degree measures around our circle. And then if we take the cosine of those degrees, we would get these values. And so if we think about the unit circle, we have 0, this is pi over 2 or 90 degrees, pi, 3 pi over 2, and back around would be 2 pi. So we know that if we're taking the cosine of these values instead of the sine like we did yesterday, the cosine of 0 is 1, the cosine of pi over 2 is 0, the cosine of pi is -1, and the cosine of 3 pi over 2 is 0. And so notice that our max and min values, again, just like sine, are split into those 4 equal parts. So in radians, again, cosine of 0 radians would be 1. Pi over 2 is 0. This would then be -1, 0, and 1. So unlike the sine that starts at 0, 0, the cosine of 0 starts at a y value of 1. And then it goes at pi over 2 to 0. Then at pi, we have -1, and 3 pi over 2 is back to 0, and 2 pi is at 1. So this would be our first wavelength. So let's actually look at this on this graph right here. So if we are graphing the cosine, again, this is all that we're doing. So we know the cosine of 0 is 1, so that's why our graph's starting up here. And then it's just going around our unit circle. And now we know the cosine of pi over 2 is 0. And if we keep going around our circle, we have then our first wavelength of our cosine graph. So let's compare this to the actual sine graph. So just to look at the sine graph in comparison, remember the sine of 0 is 0. And so when I'm going around my circle, we see there's the difference. So they look very similar, except for the cosine graph, instead of, again, starting at 0, starts at 1 and then goes down to 0, -1, 0, 1. So those are the values that we use for our cosine graph, parent graph. So you can see the maximum is at 1, just like sine, and the minimum's at -1. The domain is all real numbers because we can go around our circle infinite many times in the positive and negative direction. And so we could continue a second cycle of this by just counting our key points. And so let's go over these definitions again. Remember, the midline is the distance between the maximum and the minimum value. So that would be right here, because our maximum is at 1 and our minimum is -1. So the distance between would be 0. And then the length of one period, or one complete cycle, is the period of the graph. And so our period to complete one time around our circle in radians is 2 pi. And then, as we said, we want to sketch the 5 key points. So the 5 key points are the maximums, the minimums, and the intercept where the graph crosses the midline. So those were these values here. So 1, 2, 3, 4, 5. Those are our 5 key points. So to get the intervals on our x-axis that we are going to be using to help us graph, we take the period and divide it into 4 equal parts. So 2 pi divided by 4 is equal to pi over 2, and that's why we count by that on our graph. And so if we were to keep going, so this was 1 pi over 2, 2 pi over 2 is pi. So if you actually want to write 2 pi over 2 and then reduce it on the x-axis, this is 3 pi over 2. If you add another pi over 2, you get 4 pi over 2, which is 2 pi. And 5 pi over 2 doesn't reduce. And 6 pi over 2 is 3 pi. 7 pi over 2. And then 8 pi over 2 is 4 pi. And of course, we can also go in the negative direction. Negative pi over 2, negative pi, and -3 pi over 2. We're just repeating those values, but on the opposite direction on our axes. So if we want to complete another cycle, we know that after 2 pi is 5 pi over 2, then 3 pi, 7 pi over 2, and 4 pi. And we're just repeating the values. So we had 1, 0, negative 1, 0, 1, 0, negative 1, 0, 1. So on our graph, at 5 at pi over 2 would be at 0, negative 1, 0, 1. So that completes a second wave, and we can do the same thing going the reverse direction on the other side of our y-axis. So now we have 3 complete cycles of my cosine graph, and we also talked about the distance from the midline to the max and min values is called the amplitude of your graph. And remember, the amplitude is always a positive value. So if we look at our graph right here, then we know that this distance here and or any of those distances, let's do a minimum, this distance here, that's called an amplitude. And so you can see the distance for the cosine parent graph is 1 because we're going up 1 and down to negative 1 for our graph. And that's because of our unit circle. So we can also do transformations of our graph just like we did for sine. So if I go back over here, let's go ahead and take a look at this equation. So we're not going to talk about C, that's moving your graph left or right, and we're not going to move our B value. We're just going to look at A and D. So remember, A stands for our amplitude. So when our amplitude is bigger than 1, we're vertically stretching our graph. And notice it doesn't change the midline of our graph. It just makes it oscillate up or down more from the midline. So what happens when the A value is negative? So if it's a fraction still here, but when it's negative, notice that a negative value makes it reflect across the x-axis. So it would, again, reflect across that midline, so it would go down instead of up. So let's put this back at 1 for our parent graph, and let's look at what the D value does when we're adding D. Just like sine, when it's a negative D value, it goes down from our parent graph, and when it's a positive value, it goes up. So those are the transformations that we are looking at. And then again, later we'll talk about changing our B value. But for right now, we're just going to use our B value as 1 and our C value as 0. So again, here's the general transformation equation. And again, we're using our B value as 1 right now. So for this, then our A value is that number in front of the cosine in this case, which is 4. Remember, it's always the absolute value of that number. So 4 is the amplitude. The midline is our D value, which is right here at negative 1. And then remember, we're not going to change our B value from 1 for right now, and that means we're not changing our period yet, which is still 2 pi. So to get the key points, it's the period divided into 4 equal parts. So 2 pi divided by 4 is pi over 2, which hasn't changed from our parent graph. And so again, whenever you're graphing these, I do want you to, I know it's repetitive right now, but I do want you to write down all these values. So we have 1 pi over 2, 2 pi over 2 is pi, 3 pi over 2, 4 pi over 2 is 2 pi, 5 pi over 2, 6 pi over 2 is 3 pi, 7 pi over 2, 8 pi over 2 is 4 pi, 9 pi over 2, 10 pi over 2 is 5 pi, 11 pi over 2, and 12 pi over 2 is 6 pi. And again, all I'm doing is counting plus pi over 2 each time to get these values and then reducing them on my x-axis. And if you want to count by ones on your y-axis, like I'm doing, you can, but you don't have to do each value. You can skip every other one. All right, so the first thing I would do, just like our graph for sine, as I would graph the midline, because I know my graph has to oscillate back and forth between that midline. And so looking back at our cosine parent graph up here, notice that sine starts on the midline on our y-axis, but cosine does not. Cosine starts above. So in this case, that means instead of starting at 1, we would be starting 4 above because that's our amplitude. So I'm going to start up here from the midline. I'm going to count up 1, 2, 3, 4. And then we know we always have to go back to the midline. And since I was above here, then I would be down 4 from the midline for the next point. Back to the midline and above 4. So that gives me my first cycle of my new transformed graph. So that would be the equation that we would graph. Your domain for this, of course, is going to be all real numbers because we can keep going on and around our circle. And our range would be from -5 to looks like 3, and we're including those points, so they of course are brackets. So now that I have my my values, I'm going to keep on repeating those for another cycle. So if we do another cycle, we're just going to go back to the midline and then 4 below, back to the midline, 4 above, and back to the midline. So that would give me a second cycle. And then if we repeat those values, we would get a third cycle. We can do a negative, let's see, half of a negative cycle. And again, the midline was at y equals -1. And that would be it for my new transformed graph. So the key is to remember that, I'm going to make a note up here, that cosine graph graph start on the y-axis above or below. So above if your a is positive, and if a is negative, then it would be below. I guess I should write this with the plus in front. The midline. Remember, sine starts on the y-axis on the midline, cosine is above or below, depending on if there's a negative in front. So let's look at the next equation, which is going to have a negative for our a value. So looking at number 2, this is my A, B, and D. So my A, again, we want the absolute value of A because it's the midline, or excuse me, the amplitude. So our amplitude is 3, my midline is 2, my B value is 1, which means my period is still staying as 2 pi. The key points are still 2 pi divided by 4, which is pi over 2. So you can just count again for your x-axis by pi over 2. So 1 pi over 2, 2 pi over 2 is pi, 3 pi over 2, 4 pi over 2, 5 pi over 2, 6 pi over 2, 7 pi over 2, 8 pi over 2, 9 pi over 2, 10 pi over 2, 11 pi over 2, and 12 pi over 2. And again, just make sure to reduce those values. And so for this, we know that our graph midline is now at 2. And for our amplitude, since we have a negative here, we need to reflect across the x-axis. So that's the midline for us right now. So instead of starting above the midline up 3, we're going to start below the midline down 3. And we always have to go back to the midline, and then 3 above, back to the midline, and 3 below. So that gives me my first wavelength, and we can see the domain is all real numbers. And the range is from -1 brackets to 5 brackets. And then again, we can continue another cycle. And then if we do another one, we would get a third cycle. And we could do half of a wavelength on the negative side. And that would be my graph. So that is it for the cosine, which again, the cosine and sine graphs look very similar to each other, which is why it's always important to make sure you label everything. And again, the difference is that the cosine graph starts on the y-axis, again, above or below the midline. And so if we go back to those transformations, so remember when it's a negative, it would start below, but if it's positive, it goes above, and then that d value just shifts your graph up or down. And again, if we compare our sine and cosine graph, we can see that, again, the sine graph starts at 0 and the cosine's graph starts at 1. So they look very similar to each other. And that is it for our cosine graph notes for today.